2085, humanity's first colony on Mars, called New Horizon, shimmered under a pale orange sky. Every day, the settlers worked to grow food, find water, and build a new future. One evening, as the twin moons rose, a young engineer named Lena spotted a strange blinking light on the horizon. Curious, she grabbed her rover and drove out alone. After an hour, she found something incredible, a small, silver sphere half buried in the sand, pulsing softly. When she touched it, a holographic map of Mars appeared in the air, showing places no human had ever been. A message in an unknown language floated above it. Back at the colony, the scientists worked to decode it. Finally, the truth came clear. It was a welcome message, left thousands of years ago by an ancient Martian civilization. Mars had been waiting for visitors, and now they had finally arrived.
A constant stream of charged particles emitted by the Sun. As Mars' core gradually cooled, the dynamo effect weakened, leading to the eventual loss of the magnetic field. With the magnetic field gone, Mars's atmosphere was left vulnerable to the persistent solar wind. Over time, this solar wind stripped away much of the atmosphere, causing the atmospheric pressure to drop significantly. As the atmosphere thinned, it became increasingly difficult for liquid water to exist on the surface. Water that might have once been present in liquid form began to evaporate and escape into space. The thinning atmosphere also led to a weakened greenhouse effect, resulting in a sharp drop in temperature. Mars transitioned from a warm and wet environment to the cold, dry world we see today. As the planet cooled, any remaining liquid water froze, becoming surface ice or permafrost hidden beneath the surface. But something didn't add up. If our theories were correct, even after accounting for the water lost to space, Mars should still have a significant amount of water. The frozen water in the polar ice caps wasn't nearly enough to account for it all. This raised the intriguing question: where is the rest of the water hiding on Mars? And if it still exists, could it potentially support life as we know it? The answer came from NASA's InSight lander, a groundbreaking mission that aimed to explore Mars's interior structure. Unlike previous missions focused on surface exploration, InSight was designed to dig deeper, literally and figuratively. Its mission was to investigate Mars's seismic activity, heat flow, and internal composition by looking beneath the crust. Throughout its 4-year mission, InSight detected more than 1,300 Mars quakes. These quakes originated from meteor impacts and rumblings from volcanic areas, all of which produced seismic waves that allowed geophysicists to probe the interior. Hidden within the signals of these seismic waves was a surprising discovery: a large reservoir of liquid water. The technique used to make this discovery is similar to what scientists use on Earth to study our planet's internal structure. By analyzing how seismic waves behave as they travel through different materials, seismologists can infer the properties of those materials. To locate this hidden Martian water, scientists applied a mathematical model of rock physics similar to those used on Earth to map underground aquifers and oil fields. The model revealed that the seismic data was best explained if, deep below the surface of Mars, there existed a layer of fractured igneous rock with its cracks filled with liquid water. Igneous rocks are formed from the cooling and solidification of molten rock material, either magma below the Earth's surface or lava on the Earth's surface. This process occurs in various settings, such as beneath volcanoes or as lava flows after volcanic eruptions. As igneous rocks cool and solidify, they can develop fractures and cracks. These fractures can create pathways for water to flow through the rock and be stored in the spaces between the cracks. Over time, these cracks can widen due to processes like weathering, allowing even more water to seep in. Though igneous rocks are not typically the most porous or water-retaining type, they can still hold water under certain conditions. While the discovery is essential in our understanding of Mars's water cycle, this layer is buried at depths between 11.5 and 20 kilometers or 7 to 13 miles, making it far too deep for future astronauts or current technology